Hi everyone. So in this video we finalize the discussion or the description of long short-term memory cells by discussing the output gate. Right, so I would like to start with highlighting this note here. So it says that the delayed state can be input to all three gates, right? But at the same time we already mentioned that h of t minus 1 can be input to each of the gates as well as the input nonlinearity. So what's the difference here? The difference is that s of t is different from h of t, right? So this s of t can go through a one-time delay step, right? And then be input to each of the three gates, right here. And the difference is that a time step t, this is s of t, right? While the output is h of t. Right? So h of t could be different from the s of t, and the difference is basically the output is going through the output gate as well as the output nonlinearity. Right? So this comment here now makes sense because it says that even s of t minus 1 can control how the gates open and close in each time step. Right? So now let's discuss how to obtain h of t from s of t. Right? Okay. So hi of t for the LSTM unit I at the time step t, there is a nonlinearity of a tanh of si of t times the value of the output gate, right? So si of t goes through a tan hyperbolic nonlinearity and then multiplied by the output gate, and the output gate, it has a sigmoid nonlinear activation, and then of the bias corresponding to the output gate plus weights multiplied by the input plus weights multiplied by the output at the previous time step h of t minus 1. So tanh here, or in general, recurrent neural networks, for their outputs, they use what's known as squashing nonlinearities or squeezing nonlinearities, and that is to avoid explosion and vanishing in both the forward and backward propagation, right? So tanh has a reason of why it's commonly used for the output of the hidden state to handle the fact that this hidden state will be exponentiated by a large number in forward and backward propagation, and that number corresponds to the sequence length. Okay, so the natural question to ask is basically, why would we want to suppress the output, right? Because it might not be useful. So let's think of the units we discussed before, the leaky units and the skip connections. Implementing leaky units can be straightforward, right? So leaky units, what do? They basically have an alpha times the previous state plus 1 minus alpha times the new input. So in order to implement a leaky unit, for this LSTM structure, you can think of the input gate and forget gate being complementary to each other. These are the alpha and the 1 minus alpha. And basically they control how much I would allow the new input and how much I would allow the previous state. Right? So to implement a leaky unit, the unit should learn, or the LSTM cell should learn to make the input and forget gate, their outputs complementary to each other. Okay? And pass the output normally. Now, if I were to implement a skip connection, then I would basically set up the forget gate such that the previous state is passed as is. So the value here equals 1. The past state is passed as is to the current state, and the input gate is completely closed, meaning that the input gate, its output equals 0. So to implement a skip connection, there will be a 0 here and the 1 here, right? So there will be a 0 here and a 1 here, so that you let the previous state pass to the current state. But what's more is that while I am implementing a skip connection, I will also close the output. I will suppress it, because that output is not useful until I reach the point. So let's say I'm doing a skip connection between point 10 in time and point 1000. Then I will close these outputs just for that LSTM cell. And I will pass the skip from across the delay of the skip connection from time step 10 to time step 1000, and then I will reopen the output again at time step 1000 and proceed normally. Right? So thereby, one LSTM unit can learn to do a skip connection over time. And remember that this would not be the only unit in the layer, so you would have many units in the layer. So these units can learn to do skip connections of different lengths or to implement leaky units, and thereby their diversity can capture different time scales and implement a diverse set of mechanisms for capturing these different time scales, right? So LSTM, to summarize, allows for a lot of flexibility of learning different mechanisms to capture long-term temporal correlations while mitigating the problems with capturing such correlations, such as the vanishing gradient issue that we discussed before. Thank you.